When we calculate prime factors or LCM or HCF, what we typically need to do is need to see that if the number is divisible by 2 or 3 or 5 and so on. So essentially what we are doing is we are checking the divisibility by a certain number. So let's go over different rules or tests of the divisibility. Let's start with 2. Now this is very easy. If there is 0 or an even number in one's place, that means if the number is an even number, then it is divisible by 2. Let's look at some of the example. 26, 6 is in one's place. It is an even number, so it is divisible by 2. 70, there is a 0 in one's place, so 70 is divisible by 2. 25, 69, 363, all these numbers have an odd number in the ones place and are not divisible by 2. Next is the divisibility by 3. To check the divisibility by 3, what we need to do is take the sum of its digits and see if that sum is divisible by 3. Let's look at some of the examples. 27, add 2 plus 7, take the sum of its digits. 2 plus 7, the answer is 9. 9 is divisible by 3, so 27 is divisible by 3. Similarly, 324. 3 plus 2 is 5. 5 plus 4 are 9. 9 is divisible by 3, so 324 is divisible by 3. Now in case of 83, 8 plus 3 is 11. 11 is not divisible by 3, so 83 is not divisible by 3. 1000, the sum of the digits is 1, so it is not divisible by 3. Now divisibility by 4. What we have to do here is check the last two digits. If the last two digits are divisible by 4 or are zeros, then the number is divisible by 4. Now in 100, in case of 100, the last two digits are zeros, so it is divisible by 4. In case of 264, last two digits are 64. Is 64 divisible by 4? Yes. Why? Because 16 fours are 64. Therefore 264 is also divisible by 4. Now look at 150. It is an even number, so it feels like it would be divisible by 4, but it is not. The criteria says last two digits should be 0. That is not the case. Only one digit is 0. But you actually can check it by trying to divide 150 by 4, and you will see it is not divisible by 4. Now divisibility by 5. It's very easy. It's like a table of 5. 5, 10, 15, 20 and so on. So what you need to have is you should have either 0 or 5 in one's place, and then the number will be divisible by 5. So here are some examples. 45, 475, 2000, whereas 53, 566, these are not divisible by 5. Now divisibility by 6. If the number is divisible by both 2 and 3, then it is divisible by 6. Let's look at some examples. 132. 132 is an even number, 2 in the ones place, so it is divisible by 2. Let's take the sum of the digits. 1 plus 3 equal to 4, plus 2 is 6. 6 is divisible by 3, so 132 is divisible by 3 as well. So it is divisible by 2 as well as 3, that means it is divisible by 6. Now let's look at 99. 99 is divisible by 3 because the sum of the digits is 18, but it is not an even number and not divisible by 2, and therefore it is not divisible by 6. Now 130 is an even number. There is 0 in one's place, so it is divisible by 2. So let's take the sum of the digits. 1 plus 3 is 4. 4 is not divisible by 3. So the number is not divisible by 3. That means it will not be divisible by 6. Let's see some more divisibility tests. Whether the number is divisible by 8. What do we do here is take the last 3 digits and see if those are divisible by 8 or those are zeros. Now in case of 1000, last 3 digits are zeros, so it is divisible by 8. In case of 10,360, we have to look at the last 3 digits, 360. See, this particular criteria for 8 is really useful for big numbers because you are checking the last 3 digits. You can actually take the last 3 digits, try to divide it by 8, and based on that you can figure out about the big number. Now in this case 10,360, last 3 digits 360, 360 is divisible by 8. You can actually try it out, and therefore the number is also divisible by 8. In case of 1020, last 3 digits are 0 to 0, which is 20. 20 is not divisible by 8, and therefore 1020 is not divisible by 8. Now divisibility by 9. It is quite similar to 3. If the sum of the digits is divisible by 9, then the number is divisible by 9. Consider 81. 8 plus 1 is 9. 9 is divisible by 9. 1143. 1 plus 1, 2. 2 plus 4, 6. Plus 3, 9. So the sum is divisible by 9. So the number is divisible by 9. Now consider 649. 6 plus 4 plus 9. The sum is 19. 19 is not divisible by 9. So the number is not divisible by 9. Now divisibility by 10. Very easy again. There should be 0 in one's place, like the table of 10. And here are some examples for divisible and not divisible numbers. Now divisibility by 12. If the number is divisible by both 3 and 4, then the number is divisible by 12. Here are some examples like 132, 96, divisible by 12 because these are divisible by 3 as well as 4. 100 is divisible by 4 but not by 3, so it is not divisible by 12. 15, in case of 15 you check the divisibility by 3 as well as 5. So if you look at 90, it is divisible by both 3 and 5, whereas 130 is divisible by 5 but not by 3, so it is not divisible by 15. So these are some of the rules, or you can say tricks, you can use to check the divisibility, especially when you are doing prime factors or LCM or HCF.